Hello, I'm Mrs. J, and today we're going to finish 13.1 and 13.2. The total cost C of X in dollars to manufacture a quantity X of weed killer in hundreds of liters is given by C of X equals X cubed minus 2X squared plus 8X plus 50, where C of X is C of X increasing and decreasing? So the first thing we have to find is the derivative. We take the derivative of this, 3x squared minus 4x plus 8. Now to find the critical numbers to see where increasing and decreasing change, we need to set that equal to 0. This one is not factorable, so we need to use the quadratic formula. If we use the quadratic formula, negative b plus or minus the square root b squared minus 4 times a times c all over 2 times a. Now when we calculate what's inside the radical, we get a negative 80, which cannot equal 0. Oops. This is our x value. But we can't have the negative under the radical, so it will never equal 0. Which means that it is either always increasing or always decreasing. So what this tells you is that the increasing and decreasing does not change. We need to look at the graph to see more. This is a cubic graph, which resembles a snake. So we know it's going this way because it's positive, so it's always increasing. But to look at the graph, you can plug this into your calculator with this window. And I already did that. This one. And my window, negative 4, 4, yep, hit the graph. Notice it's always increasing. So it is increasing from, well, negative infinity to infinity. But when you think about the story problem, X is the amount of weed killer, you are not going to have a negative amount. So technically, in the terms of the problem, it is 0 to infinity. And it's never decreasing. So you want to be careful of that with story problems. If a negative amount doesn't make sense, then you start with your 0. I numbered it. The cost in dollars for Q units of an item is this. And P is the price. So first thing we need to do, we don't have revenue, so we need to find revenue. Remember that revenue is price times Q. So we need to take Q times 90 minus 0.02Q, which gives us 90Q minus 0.02Q squared. Profit is revenue minus cost. And so if we do that, we have a negative 0.02Q squared plus 65Q. 90 minus 25 would be a positive 65Q minus the 5,000. So that's our profit function. We want to take the derivative of it, because to find critical numbers, you need to take the derivative of it. Other reason, the number of Q that produces a maximum profit. To find max and min, that's where your increasing and decreasing change. So you need your critical number. So if we take the derivative, we have a negative 0.04Q plus 65. Once you take the derivative, you set that equal to 0 to find your critical number. Bringing the 65 over and then dividing by the decimal. Q equals 1625. So 1625 is the quantity that will produce a maximum profit. And Q is in units. So 1625 units. Now let's look at the graph. It should have a high point at 1625. So if we plug in the equation, which is the second one, and then I go to the window, negative 3,000, 3,000, and then negative 50,000. Let's see the high point. That's at 1625. The price per unit for the maximum profit, our price would use the price equation. So price equals 90 minus 0.02 times the Q, which was 1625. And that will give us the price. The price per unit is $57.50. So if you calculate this, you get $57.50. To find the profit, you plug in your profit function. We just graphed this, so we could go to the table, second and table, type in, what was it, 1625? Yeah. And hit enter. 47,813. And it said dollars, so it's in dollars. So if we sell 1,625 units at $57.50 each, we'll make $47,813 in profit. Okay, let's try a couple more that you're going to see in my labs and probably on a test. But we want to find the critical numbers and where it's increasing and decreasing. Remember, to find the critical numbers, you take the derivative. This is going to have a product rule. So it's the first times the derivative of the second. Exponential rule is the original. It's a -2. Yeah. Okay, so that's e to the -2. It's the original function times the derivative of the exponent times the natural log of e, which is just 1. And I'm running out of room. I need to be able to fit the whole thing. Okay. Plus the second, e to the -2, times the derivative of the first, which is just 1. Now we want to set that equal to 0. So I just rewrote it so you could see it a little better. But the first one is the derivative. This is to find the critical numbers. Now it looks complicated, but we have three terms here. 1, 2, and the 0 makes 3. Now, a lot of times when we have a common factor, we divide it out and get rid of it to make it smaller. You can do the same thing here because e to any power cannot equal 0. So we can divide by it. So when we divide by it, this cancels and we have -2 times x minus 2. Here it cancels and leaves a +1 equals 0. Then distribute -2x plus 4 plus 1 equals 0. -2x plus 5 equals 0. Subtract the 5. And divide by 2. X equals 5/2. So our increasing and decreasing change at 5/2. And this is our critical number. Now to see where the increasing and decreasing is, we can graph it. We want to plug in the original, x minus 2, and then e to the x, and -2x. So it looks like this. Plugged in the original. And then I'm going to go to the window and type in 0, 3, 1, -0.05, and 0.05. Then graph. It's not showing up so well. Let's see if we make this a 30. Yeah. Okay. Notice we weren't seeing this. So if you make this, let's just make it a 30. We'll just add a 0. See how it goes up right there and then comes back down? What it's doing is going like this. With different values that you can kind of see how it's going down. It was easier when it was closer to see that little bump, but there's a little bump there. So you can move your window around a little. Try the 3, try 30, try 20, and you can kind of see how that changes your graph. But it's the same graph either way. So it's increasing and then it starts decreasing. And we know that where it changes, it's increasing and decreasing is at 5/2 because that's our critical number. So it starts out increasing from -infinity until 5/2. And then it decreases from 5/2 to infinity. One more. First thing, take the derivative. Remember, this would be to the 1/2. So it would be 1/2 times x squared plus 3 to the -1/2 times the derivative of the inside, which is 2x. If you want to simplify, 2 times a half is just x over x squared plus 3. Now we want to set this equal to 0. Because remember, we need to check where the denominator is 0 also, because increasing and decreasing could change. So setting the top equal to 0, we get x equals 0 as a critical number. Setting the bottom equal to 0, square both sides. We get x squared equals -3. Well, we can't take the square root of that, so there's no other critical number. It's just this one. Next thing we want to do is graph it. When you graph it, plug this into your calculator. So it's square root x squared plus 3. X squared plus 3. And close your parentheses. So that's our equation. This one. That's our equation. Then we're going to put this window in. Just tens. -10, 10, -10, 10. Graph. And that resembles a parabola. Not like that. And the increasing and decreasing change at 0 because that was our critical value. So it's decreasing and then it increases. It decreases till it hits 0. And then it increases from 0 to infinity. So the biggest thing is making sure you know your derivatives and then being able to set them equal to 0 and solve. That covers 13.1 and 13.2.